Hello everyone, welcome back to Conarchy YouTube channel. In our previous video, we learned how to define our material properties, that's our concrete and our rebar. So we are done defining our material. So what we have to do next is to define our section properties. We know when it comes to reinforced concrete design, there are some main structural elements that are really needed. That's our slab, our beam, our column. Also, we'll get to the foundation sooner or later, but we are going to be talking about our beam, column, and our slab. So these are the three main sections we will have to define in today's video. So just get ready since we are about to start. And don't forget to like and subscribe to our channel. If there's anything you want to get to know more about, just comment in the comment section and I'll get back to you as soon as possible. Let's get started. Okay, so this is our grid lines that we drew in our, I think that was 2 videos back here. So this one, so we have our grid lines and we've already defined our material properties. So we've defined our material properties, so we are about to define our section properties. So just like where we did our material, just go to define and come to section properties. So with the section properties, our beam and columns will all fall under our frame sections. And when it comes to our slab, all we have to do is come here and define our slab. But we're about to define our beam and our column. So let's go to our frame sections. So we have some various frame properties here. These are some of the common ones in ETABS. We can just choose, just delete all of these and create our own, or you can also tend to use these too. But let's start with creating our own property. So first of all, we have to go to add new property. So this is the frame property shape type. We have our rectangular section, we have our circular section, we also have our concrete T section, and these are various sections. So this is the concrete part. This is the steel. This is the steel composite. The steel composite is just the steel and the concrete. So when we talk about composite, like 2 different materials that we are using for the section. And you have our special, but you'll be sticking with it's a concrete design we are doing, reinforced concrete. So let's go to our concrete. And so our section, let's go back to our pic. So this is our plan view of our building, and we have column type C1, column type C2, and we also have our beam sizing here to be 400 by 300 mm. So we are going to define all these sections. So we have 2 columns to define and we have just 1 beam and 1 slab. Our slab is going to be the same throughout. So let's just go back to our app. So we're just going to pick our rectangular section and we are just going to modify this. So let's go with our first section. That's, let's say B1. We are about to define our first beam. So is it B1? So you can just name it like with any name or unique name that you want. So this is just a property name. So we have our material here. So in our beam we have our concrete and we also have our rebar inside. But the material we'll be using here, in our previous videos, we already created like a concrete we'll be using throughout our design. That was C30. So that's the material we are going to use in our beam. So we just go through and we have, okay, C.30. If you quite remember, this is the material we created. So C.30. So it has a compressive strength of 30 Newton per millimeter square. So this, we are just going to change, you're not going to change anything here. So the display color, you can choose to also change that one too. And we have our notes. So this note, where you can just make a short note about your section. Any short note you want to make about the section, maybe it has a cover of 25 mm, whatever note you want to put in, you can just input them here. So you're not going to change anything. Our section shape, rectangular, is a concrete rectangular. We're going to keep that. And let's come to our section dimensions. So let's go back to our drawing. So in our drawing, we know our beam size to be 400 by 300 mm, and we know that the depth is 400 mm and 300 mm. always the bigger one is the depth, but in reading of these, it's just the depth and the width. So 400. So our depth is 400. And you also notice when I change the values here, the section also over here also changes. So just look at this. So 400, and I'll just tap enter. It just changes. And I'll also change the width to be 300. That also changes. So this is how my beam is going to look like, the dimension of my beam. So we are just going to modify our reinforcement. These are the reinforcement. I'm just going to modify that one too. So first of all, the software doesn't know that it's a beam or a column we are defining. So we have to just make some assumption. We have to just pick one of these. So this is just a column and this is a beam. So in case you are defining a column, you just select the column, and if you are defining a beam, you just select the beam. We are defining a beam section, so we are just going to pick this beam. So just take this list and look at here. We have our longitudinal bars and we also have our confinement bars. Mostly we created some materials. So that's the H1 and the R1, and we know that the H1 is our high tensile and the R1 is our mild steel. So with the longitudinal bars, we are going to go with our high tensile we created. That was H1. And our confinement bars, these are the ties. Those links around the ties, these are just small reinforcement that they hold the longitudinal bars with. I'm hoping you guys know what I'm talking about. So for that one, we are going to stick with our mild steel. That's our R1. So R1 for the confinement bars. And we have our cover to longitudinal rebar group. So when designing the beam, this is also an important factor that you have to take note of. We have cover to longitudinal rebar group centroid. That's the distance from the surface of your beam to the middle of the rebar. So let me just pull up an image that will make you understand what I'm really talking about. So we are going to take this as our beam that we are defining, and what the value that ETABS app is expecting us to input is this one, the D2. And the D2, it's the cover, the distance from the surface to the stirrup. That's the cover. And the size or diameter of this stirrup. So this is a stirrup or a link, depending on if it's a beam or a column. So these are the stirrup. So if you don't really know how they look like, these are it. It's just confinement bars that are just around the beams or columns all over, like at centers, maybe 200 center to center. These are the stirrups. So here, let's say we have a cover of 25 mm and we have a stirrup of 8 mm, or let's say 10 mm. Let's stick with 10 mm. And this is a reinforced bar, that's maybe 16 mm. So the distance from here is the cover plus the diameter of this stirrup plus half of this diameter. So let's say our beam has 25 mm cover plus 10 stirrup, so that makes it 35. Then this one is 16, half of it is 8, so 35 plus 8, then we have 43. So that's what the app is requiring here, not the cover of the beam. So we have to just take this value out and input 43. So this is not a standard value, so depending on your cover dimension, your stirrups you are using, and also the bars you are using, so it's the cover plus the stirrup diameter plus half the diameter of the main bars in the beam you are designing. So that's it for cover to longitudinal rebar group centroid, the center of the diameter of the main bar. So this is the cover we'll be using. So we are not going to specify any number of bars in our beam, because this is what is the job of the software to do. The software is going to run the analysis and is going to give us the area of reinforcement, and it will specify the number of bars that will be required in that beam. So our job is not to specify the number of bars, just the sizing and the cover and everything. So that's it. That's what we are just doing. So once I'm done just giving these various parameters, I'm just going to click on OK. So we have our C30. I've done the dimension. I've also modified the rebar. So right now I'm done with the beam. So I'll just click on OK. So now we have our B1 here. So that's our beam. So let's go back and create our columns too. So we have to add new property. It's also a rectangular section. And we know that we have two types of columns in our drawing. We have column type C1 and type C2. So let's create type C1. Type C1 is a 300 by 300 column. So let's create that one. So C1. So that's the name. And the material inside the column, the same concrete, compressive strength of 30. So C30. And that's going to change anything here. So the notes too, you can just make a short note for that one too. The shape, that's a concrete rectangular. We are going to keep that, and we are just going to modify this place too. It's 300 by 300. So we are just going to change these parameters. So we have our depth to be 300 and our width to be 300. So that's the size of the sizing of our column. So now all we have to do is modify our reinforcement in the column. So we just click on the modify or show rebar, and as I said earlier, you have to just specify if it's a column or a beam you are defining. Since it's a column, I'm going to stick with this, so I'm just going to check the column. And our longitudinal bar, just like what we did for the beam, we are going to pick the H1, that's our high tensile for the longitudinal. That's the bar running through the column, and this is the confinement, that's our thigh. So we are going to go with the mouth to that's R1. So let's come back here, reinforcement configuration. So our column is a rectangular section, so rectangular section, but just in case yours is a circular section, you just pick the circular, and you can also check the spirals too. So it's a rectangular, so you just take this and the ties. So this is also one important thing you have to know. We have reinforcement to be checked and reinforcement to be designed. For the reinforcement to be checked, let's say you already have a model, you already have a building plan or a building sections where we have building plan where we have your various sections, and you want to check if those sections are adequate to just hold the building together, if they are not going to fail or anything. So for that one, you already know that this column has this column has 4 reinforcement bars in it. It just has 4 bars. So for that one, you are the one supposed to specify the number of bars inside the columns. So this one, you already have a work there, your drawings and everything. You know the number of rebars you are going to use in your column. That's where we pick the reinforcement to be checked. So it will just check if your design is intact, then your design won't fail. It will just pass with everything. That's where you check it. But now we are about to design ours, so we don't really know the number of rebars in our columns. We don't know the number of bars we will need in our beams. So we are going to check reinforcement to be designed. So the reinforcement to design, all we have to do is just give it a cover, and we are taking a cover of 25 mm. So with the number of longitudinal bars, we are not going to specify these in the 3D direction phase and the 2 direction phase. We are not going to specify this because we are now come to design for the app to also pick the number of bars that is required in the column. So we are not going to change any value or input any value here. And we also have longitudinal bar size. But let's say we are going with size 16 mm, and also the confinement bar, that's our links, so maybe 10 mm. Let's stick with it. So with that, aside this, we are not going to change anything here. The software is going to determine everything for us. So once you are done, just click on OK, then OK, Okay, so we already have a frame section there. So right now we are done with modifying our reinforcement in our column, giving the section dimension and everything. So now we are done with this. So all we have to do is just click on OK. So right now we've created our column type C1. So we have to create our column type C2. So instead of just going to add new property, you can just make add copy of property. So you're just going to copy this C1 and you just make some modification to it. So add copy of property and you just name it at C2. And also the material, since it's just a copy, everything is going to remain the same. So you have to change the dimension. We know that column type C2 is 450 by 450. 450 by 450. Modify these column. So everything is intact from the first column we created. So okay. Then okay. So right now we are done creating our beam and our two columns. So what we have left is for us to define our slab. So okay, so just go back to define section property and we have slab sections. So this is where we are going to define our slab. So slab sections, you have slab 1, slab 1. These are some various property there, but since we don't really like that one, we are just going to create our own. So add new property. So let's name it as 200 mm slab. 200 mm. Oh no, let's take 180 mm slab. So it's up to you what you want to name your properties, the name you want to give them. So with the slab material, we are going to stick with our C30 that we created and modify. And now we have our modeling type.
So with the modeling type, there's one thing we also have to take into consideration. It's a very important thing we need to change. So we have various options here as the shell thin, shell thick, and also membrane and layer 2. So I'm going to explain each and every one of these, and I'm going to show you which one you are supposed to use for defining your slab. So first of all is the shell thin. So for the shell thin, it assumes that the slab thickness is small, meaning like the bending stress and stress deformation are very minimal. So for here, we do not need a shear in our slab. We mostly do this when we are designing our normal slabs. We use, in the normal designing, we do these small slabs. So for this one, it provides both bending and membrane behavior, but does not account for transverse shear deformation in the thickness direction. So that's for the shell thin. And also we have the shell thick also over here. So for the shell thick, it incorporates like transverse shear deformation, making it ideal for thicker slabs, mostly when you're working with thicker slabs, and it accounts for both bending and in-plane action. And also for the membrane, it actually ignores bending stiffness entirely, and it assumes that the slab carries load only through in-plane force. That's the tensile and the compressive forces. So for this, we mostly do it when we are designing. We mostly use the membrane when we are designing shear walls or maybe diaphragm connecting to vertical structures. So that's it for the membrane. And for the membrane, like when you select the membrane, it makes the slab act in a way that it does not really receive the loads coming onto the slab. So it transfers all the loads to the beam. So you can have a very thick beam when you choose your slab to be a membrane. That means the membrane doesn't really carry more loads. So all the loads are transferred to the beam. But in the actual sense, the slab is also supposed to absorb certain loads. So that's it for the shell thin, shell thick, and also membrane. So for this slab we are defining, we are going to pick the shell thin for the definition of our slab.
Then it's a slab. So we have different types. We also have the waffle, the ribbed, but we just want a normal slab. So slab, I'm just going to give the thickness. So with the property name, I named it at 180 mm. So I'm just going to stick with that. So we have 180 mm to be the thickness. So with the slab, we don't really do a lot here. So once you are done, you just click on OK. So we have our 180 mm slab and we are done. So right now we are done defining our beam, our column type C1 and type C2, and also we are done with our slab. So right now we are done creating our various structural elements we'll be using in our design. So in our next video, we will just start with our modeling, placing our columns wherever needed, placing our beams and also with our slabs. And once we are done, we are just going to be running analysis and everything. It's going to be very interesting. So don't forget to like and subscribe to today's video. And also, if there's anything you want to know about or anything you want to just make me aware of, just leave a comment down in the comment section and I'll get back to you as soon as possible. And as always, Conarchy Engineering Consults, the pinnacle of engineering.